Okay, now I know this is a lot of videos all at once, but these are the steps that explain how aggregation works and the expected behavior and so on. Now, one of the things I did was I changed these things. This here TS device is visible to the outside world. So it includes the lib line, right? In fact, we should do that. See, yeah, that's lib. Yeah. This dev manager is just a static library, and the template thing for I still didn't fix this up, but for doing the create instance, and what I had before in here, either in here, there was another header which I've moved into a private area, which had that reference counting thing, and the devices were probably, some of them probably, this one probably still is, yeah, this now can't say that, and there is no dev manager, right? Do the other ones include that? Yeah, it's not necessary really. Real math, which one is that? It's HTTP client. This is real math, where's this, I don't know how it compiled. There is no dev manager. Oh, the unit test doesn't include that. The unit test compiled, but it's not including complex math. Otherwise, it would have complained. As far as the implementation file, this thing does include should, but it doesn't. It's not going to compile now. It's going to ask for ref manager. Real math doesn't include it. I just took it away from there. Now, complex math H could include real math H. In fact, it should. It needs to. This has to be visible to the outside world because I'm going to add a function to return a pointer to a real math. And what I'm missing in here is the dev manager. Now, I didn't think this was going to work, but thank God it works. What I did was for the reference counter, okay, I turned that into another template thing, public T, okay, and the implementations derive from ref manager of the interface, which makes them derive from the interface class. So that means that this is still implementing. It's still implementing the proper class. I believe. Definitely, because ref manager does have a piece of data, but that shouldn't matter. The function, all that matters is the layout of the virtual function table, and this here includes the two add, ref, and release in that order, and by making the template parameter equal to the interface to be supported, that means that add, ref, and release will appear in the same order that they do in TS device. Right? This thing is just deriving from a thing that derives from TS device. It does add an extra function, and that's the thing that worried me, is this virtual destructor. Now I might have to do something. It seems to be working, but it may not be. I may have to do something. There's a thing you can do. In fact, there's a keyword I learned about looking at that com stuff, which would be just perfect for this. Here, I guess. Now, what is it now? It's decl spec no vtable or something. Something like that, see? Now what that does is it instructs the compiler to not create a virtual function table layout for this declaration, right? And to postpone that, I guess to postpone that for a later part in the, or a later part during the compilation. I'm not sure exactly how it works, but if you do that, then utest will see it like this and expect, and certainly would not be able to delete this object, right? Because that would lead immediately to a access violation, right? Well, first of all, there is no destructor declared. Oh, and the destructor here is virtual. Has to be, in order for this thing to delete the T, right? Or not the T, but the class that it doesn't know of, the further derived thing. Anyway, I'll leave that out for now and just compile. So in the real math class, I've done the same thing, and I've implemented these things, and therefore I don't need to implement add ref or release. And when the release is called here, it should free the memory. Now, in order to check that, I can steal something from common here to set up the memory. Well, I could put a destructor in here and see if it gets called when I do that. But I was certain that if the destructor is virtual, it comes first in the vtable. But as far as utest is concerned, right, the first function is add, right? So I'm curious to see what happens when this occurs. It's got to work. Let's see now. It does seem to work. Let's see what happens. Oh, one other thing before going on about again, to do with the reference counting and the deleting. Where's complex? Okay. Now, this here, thing that I plan to make a function to return the address of this real math object, okay? And it again derives from, now this one doesn't derive from the reference manager, okay? It derives from, essentially from real math, alright? Now if somebody calls add ref or release on this object that's been passed to them, the address that has been passed to them, then that's going to bring them, hopefully, it should bring them to this line, which then adds a reference not to itself, but to its container, and for release to the container. So if you had one of these real maths and released it, and if you released the outer class first, this thing would still survive, and the outer class would still exist. And if you released this thing, that would destroy it. Just like if this were a real component on its own. Okay, although it's not, it's contained within this thing, but it doesn't do any reference counting. At least not as far as the outside world is concerned. It has an internal component object, which when this thing finally just goes out of scope, when the containing class is destroyed, it releases the thing that it's hanging on to. It has one reference to this thing at all times until this thing is destroyed, in which case it releases that. Now, if you had an outer, right? Let's see now. If you had an outer class and not this thing, and you release the outer class, then that will call this destructor, and this thing will get released, right? The only way to get the outer class to die is to release it completely. If somebody wants one of these pointers, right? At that point, I would call add ref on the outer, right? To add an extra reference for this pointer that I've passed back, so that everything adds up properly. As many adds as releases are required in order for everything to balance. Is it going to work? I don't know, but that's the idea. And that's why we need this outer. And that's why this thing needs to be, we can't pass this to the user, because they could call release on it on their own and just kill this thing without this class knowing anything about it. Furthermore, they will, I will add a function, a kind of query interface sort of thing to all of these device objects, TS device, to obtain another TS device if possible. So this object could be asked for this kind of object, and that can be returned. It would be returned this outer, what they call the containing unknown, or the controlling IUnknown, right? Whenever the rule in COM is, for any interface that's part of an aggregation, including the containing IUnknown thing, a request for an IUnknown pointer will return not the pointer to the particular aggregated thing, but a pointer to the containing or controlling class. Alright, so now if that's working, that would be great. Let's see what happens with just with the real math. Now in my implementation file, I've just added this thing here. There's no complex math in this at all. The reference counting though should work because this is deriving from TS device. If it doesn't, if it's unable, if the table gets messed up, then I would have to add a virtual destructor entry into the public file. This one has there's no destructor declared anywhere, nor here. And there shouldn't be, really, because the destroying is not done through delete, it's done through add ref, right? Only is that entry going to come at position 0 as it usually does, or will it come in a different spot? I think it will be a different spot in order for this to be true. But let's see. I run up to here. Well, it's still registered in my sense. And so create device will land me on this line. Which it does, okay. Now what I'm creating is this class, which derives from something that derives from TS device, and implements all the rest of the functions. So that object should contain all the right functions. Let's just see if it goes to the right place. It is on the add line, so that worked. I don't know why it works, but I'd have to look at the virtual function table, which we can do. Now this here should actually delete the object. Okay, now see, it's taken us right to the correct function because it's part of the table. The question is, where's this going to take us? I have to put a breakpoint on my put function. See if it gets there. It's declared as virtual in this class here, right? So I don't know. We'll see. It's going to delete, and we're on the. I can't believe it worked. It's amazing. It's fantastic. So the delete is deleting the right type of object. This thing doesn't know anything about real maths, and that entry has to be in the function table. And I gotta look at the virtual function table for this class. That's well, actually, this is the line that's of interest. Okay. So actually, the address of the delete operator is not at position 0. It looks like it's at position 20 over 4, I guess, right? Because the fifth can't be the fifth entry. That's 20 hex, which is or the 9th entry. Does that make sense? 2, 3, 4, 5, 6, 7. Now this is weird. Subtract and then subtract again. Oh, I see. It's switching types. This is like this is an automatic cast from one type to another, right? The thing that's going in CX is 4 bytes further back from the pointer that was handed to the user. So this thing actually is using its own, must be using its own virtual function table. EDX, where is EDX put in? Okay, I've just taken, no, -8. BP -8 goes EDX. Okay, that would be the virtual function table. The registers say DX is, it's too late. It's been wiped or in the wrong function. But it's too late. Anyway, I'm sure it's not still the same value. It could be. Let's see what this is. This is the virtual function table, my real math, right? No, that's not code. There should be jumps in here. This is all, it looks like garbage because this is just a table. But where are all the F8, F9s? Oh, just the addresses. Okay, so 110.0. No, this is 114010. Oh, there. Maybe. It ends at 4 zeros. 1, 2, 3, 4. This is the last entry, which starts with a 10. And it points to 100012D0. Zero, zero. Okay, well, I don't know. I'm not sure about that. I don't know. How did I end up here? It's all messed up. Somehow I have to go in to the delete line, run it through it again. I'm wondering where this came from. It's my special macro for this put func. It's using a special macro. I made a new thing. It tells you what went to the console. In any event, going back to this line. How does this work? I want to know which offset. It can't be 0 because 0 would screw everything up. ECX is at this pointer, right? And star of this pointer should give us the table. Move into, so now we're trying, it's doing the star here, right? Move it into this place here. So it's a negative offset, strangely. No, that's local variable. Okay, no problem. Then dereference that into dx. 1, 3, d3. It's not the same. Okay, but what is it doing now? Put that into a local variable. Compare it with 0. Checking for call to pure virtual. It doesn't have a function. Have you ever seen that error come up? Pure virtual function call. Anyway, compare. It's not 0. Push 1. Oh. So 1, and then move into EAX to this pointer. CX contains the this pointer. Star of CX. DX should be this should be the virtual function table. Let's see. Does that look like a table? Ah. I just want to see it as like a dump bin. Dump bin would be easier. 98 here. Code bytes I want. I just don't want the disassembly. Address, yes. Toolbar, okay. D 98, here it is. 6C97, okay, that's an address. 106976C. One 1006, right? 97. Yeah, it's too many. No, it should be 4. 97.6C. Okay, that's the vtable. Okay, which is just a bunch of addresses. So you call star edx. That's a call to a function. No, where is it called? Where are we again? Push 1. Now 1 is just, it's not anything but a, well, it could be, I don't know. Move into EAX, that's this pointer. No, it's not, it's a virtual function table. Virtual function table. Move into DX, put that same value, O star of EAX, which is the actual function address. For the should be for the destructor. So this address is in DX. This here, that's not the one I typed in, right? Oh no, I did. I worked that out. I typed it in, and that was, I don't know. I forget what it said now. No, it said that was the table. ECX goes this pointer. Alright, thought it already was this pointer. It was, it didn't change. EAX goes DX plus 20 in hex, which is 32 divided by 4. I won't trust myself, is 8. So that would be function 8 from DX, which is the table, right? It's not at 0, that's all that matters. But how does it wind up being 8? Oh, it is 8. So dumb. Add ref release. That's 2, 3, 4, 5, 6, 7, 8, right? But of course, as an offset from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I wonder if it matters that I listed it here. Maybe that's maybe I just stumbled on the right thing to do by putting this here. No, it can't be. It's not my doing. It's a virtual, and if anything matters, it's where the virtual keyword is used in the reference manager, where it is declared here, right? But clearly that's not where it put it. It put it at the end of the table, which is good. And that means that the function layout is exactly the same for this object as it is for what utest sees, right? So everything's going to work fine. Now, if I put in a complex math, one more test. Maybe I won't upload this now, but I want to try it, so I'm sitting here. Alright. Now I could negate this without changing anything. I need a real and an imaginary. Imaginary. Right? The negation of pi plus root 2I is this real part and this imaginary part. I'll put the right header. And then I can add a function to the complex math object that retrieves for you a real math, and that action shall increase the reference count on the containing class by 1. I'm going to put a breakpoint in here. I've got 2 ready to go. I haven't selected this one yet. Locate iComplex Math A interface. That would be A using this directory. Did I say real? No. What did I say? I thought I said real. Debug unit, oh, complex. Oh no, complex math. Alright. Now, how come it didn't hit my real math breakpoint? Maybe I took it away. Start over here. It should hit both of them, right? Here I am in the grid. Okay. It's coming from complex math. How come it didn't remember? I have to put them both. Yeah. Well, why didn't it stop here first? Oh, because that's there, I see. Never mind. Now it should work. You can preload. You can have the debugger preload a DLL so that you don't see those things change colors. Okay, here we are in complex math create. Now we'll check to see if we can make a real math. Okay, that succeeded. And now we're building a new complex math from real. This is using yet another, there are 3 runtime libraries currently loaded. Okay, reference count goes to 1 of the complex math. The reference count on this doesn't do anything. This doesn't derive from any ref manager, right? But this thing does. So it has to be released at the end. So here we are, just setting a variable. And this here, I forget what it's just constructing itself. And that's done. And we're back in main. Now, try the function F8. Here we are in neg. The real being pi and I being √2. We're going to call the real maths neg of both R and I to be stored in here. That puts us here, which then calls neg in this DLL, takes the negative of the number, stores it in this pointer, right? Which was passed in here. So star of the real part should be minus pi, and it is, but the imaginary is not done yet. Do that again. You want? So that's correct. And print it out. Now I think that this process of building one component from another, like this complex math device, its construction didn't use any mathematical operations, plus times or whatever. All it did was call functions of another class, and I think that is called composition. It's also an aggregate thing, so we've got both aggregation and composition going on here. Now this here should put me, there should be only one this should be 0, it is. and didn't. Okay, real math is being destroyed. That's good. That's from the destructor here, right? Releasing the thing that it has, and its own destructor is not. I didn't make one, did I? No, I didn't. So it won't. I don't see anything for that. I'll mention this threading stuff here, where it puts one in for you, a destructor for the class default destructor, which doesn't do anything but call some cleanup, I guess. Check for stack overruns and whatnot. Destructor, and I'm still on this line. And hopefully the memory wasn't hopefully everything was cleaned up, but the way to check for that is what I have to add. It doesn't matter if it's public or private. I can put that here, private. Whoops. Yeah, because nothing calls that except for the reference manager. Okay. Now, next time what I'm going to do is make a function to retrieve a pointer to this object and show how the add ref and release affect the UnkOuter, the containing unknown. God, I sound like a comm expert. Okay, I'll leave that here.